SILA offers the aerospace market a unique actuation solution. It provides a very high load actuation capability with very minimal and highly efficient power requirements. I've had the pleasure of supporting Wavedrives all the way through from the proposal development right through to the prototype being fully developed and tested.
Today we'll be demonstrating the SILA electric actuator, and you can see the device here. Now we'll be lifting the mass on the end, which is equivalent to 600 kilograms, or a small car and a Mini in old money if you like. One of the benefits of the SILA actuator is its super efficiency, and then what that means is if we ever have any failure or power outs, we can simply, the power's off, and push it back into position, which can't be done with conventional electric actuators. It's not that exciting what it does, it's how it does it that's exciting. It's a piston, it moves up, it moves down, but what it does do is it does this by using magnetic threads. So when the electric motor is energized, it will spin round. That will spin the one magnetic thread with it, and on the outside of that is a static magnetic thread. So really what you've got is like a nut and a screw. You drive it and it moves up and then it moves down. But the beauty with ours is that there's nothing doing this, and that's such a crucial point for the problems that are, we face so many issues like this, that if you're suddenly got a power off, well, that can stick, and okay, that might not be a problem if you're just running a robot, but if you're running a flight surface or something that's really quite crucial, then that is a big issue. So what we've got is a gap, and that magnetic gap is working in the same principle, but you've got no friction between those surfaces. The beauty then is, if that does fail, I can merely just push one out of the way of the other, and all it's going to do is go back into its riposte position, and we can re-engage, and off it goes again. No damage, nothing.
And my involvement in this project is to do with the design and the development. The technical challenges within this project are to do with scaling up, the scaling up of the magnetic materials. And you can imagine that as you scale up magnetic materials which have the same density as steel, that's a big problem for mass. So we made sure that we were on top of how those things scaled, so we're using a very, very minimal amount of those materials so that we can keep it lightweight and compact, and yet still provide this amazing sort of thrust of 6 kilonewtons.
It takes out the whole need for a hydraulic system, and that is a full system you need just to operate a piston, which is, it's not ideal. Then you've got all the fluids that go in there, and they are historically not great for the environment. So what we've got is we've got this inherently clean device that is creating no wear, no mess, no fluids. It's always going to last longer than anything that's already out there. It's super efficient. Now, we're looking at it from a green point of view, or something that's mobile. We need something that can run on batteries. The more efficient this thing is, the longer it runs on those batteries, the less downtime, the more time up in the air or doing the production line, whatever it might be, prosthetic legs. But the beauty is that we've managed to get it away from the tether that is the hydraulic system.
The back drivability of this unit is something that we're really pleased about. The fact that it can support like 600 kilograms and yet can be back driven by about 30 kilograms is a superb achievement. You can imagine that if that's in an aircraft application where there's parallel actuators and one of those actuators becomes redundant in some manner, the remaining active actuators can still function. It's not presenting a jam risk.
So one of the great benefits is that, as mentioned before, this is an ultra efficient device. It means that I don't need those huge power cables that are often associated with this sort of thing in the first place. The benefit of that is I can easily take out what's in there, put this one into the position, hook it up, and we're good to go. We don't need to build from the ground up and build a whole infrastructure around it. We can use what's already available.